Hello everyone. Today we will discuss about our next topic, that is complex number and quadratic equation. Okay, I will suggest you to first go and watch our previous classes if you didn't watch, because it will help you a lot there. Because when we will discuss function, then it is expected from you that you must understand what is function. So without wasting time, let's start. Okay, look at here. I'm writing a function fx equals to a naught plus a1x plus a2 x square plus up to an x to the power n. My dear friend, this is a function, and this function is called as polynomial function, where n is a positive integer. Yes, n is a positive integer, and an belongs to where an is a element of real set. And I already told you that what is the set in our sets theory. So an is an element of real number, set of real number. And I can write down this equation as, so the value of n can be any positive integer, that is 1, 2, 3, 4. If I take this equation as fx equals to a naught plus a1x plus a2 x square, I write down this equation where n equals to 2. So in this equation, if the value of function becomes 0, if this value becomes 0, so the equation will be a2 x square plus a1x plus a naught equals to 0. So this is a quadratic equation. This is called quadratic equation. Quadratic equation, because there is the degree is 2. And what is degree? Degree is the highest power of variable. So here degree is 2, highest power of variable. Okay, now you can see I can write down this equation as ax square plus bx plus c equals to 0. Yes, I can write down this equation in this form, because a is the coefficient of x square, b is the coefficient of x, and c is also a constant. So you can see, because here the highest power is 2, so the solution will be 2. There will be 2 values of x that will satisfy this quadratic equation. Okay, so we have to find out the solution of this quadratic equation, and we know there will be two solutions. There will be 2 values of x that will satisfy this quadratic equation, because the highest power is 2. And one thing more, here a cannot be equals to 0. If a becomes 0, then it will not be a quadratic equation. Okay, now come to the next point. Here what we have to do, we have to find out the roots. Roots means the values of x that will satisfy this quadratic equation. So first our aim is to find the roots of this quadratic equation. Before finding out the values of x that will satisfy this quadratic equation, and that are called as so before finding that, we will find out the nature. So what is the nature of those values that will satisfy this quadratic equation? So before finding out the roots, we will find out the nature. So we will find out the nature by using this formula, b square minus 4ac. If it is more than 0, then roots will be real number. If b square minus 4ac comes equals to 0, then roots will be same and real. So in first case the roots will be real number, but in second case when b square minus 4ac comes equals to 0, then roots will be same as well as real. For example, let's take an example. Suppose there is an equation that is called, this is equation x square plus 5x plus 6 equals to 0. So I will check that what is the nature of roots of this equation. So I will write down first what is a is equals to 1, v is equals to 5 and c is equals to 6. So I will find out b square minus 4ac. What is the value of v? 5 square minus 4 into value of a is 1 and c, the value of c is 6. So this will be 25 minus 24. So the value is 1 and that is equals to 0. So roots will be real. Now we find out the nature of roots, and the roots are, because we find out the value of v square minus 4ac and the value of v square minus 4ac is a real number. So the roots will be real for this quadratic equation. So now we will find out roots of this quadratic equation. There is a formula, and this formula is valid for every quadratic equation, whether the roots are real, roots are same or roots are imaginary. Then this formula is valid for all type of roots. So we will use this formula, and this is x equals to, because we are finding the value of x, minus b and plus minus under root b square minus 4ac divided by 2a. So here we will put the values. Here we will put the value of b, and what is the value of v? 5 plus minus and 5 square minus 4 into 1 into 6 and divided by 2, and what is the value of a? That is 1. So we will solve it. 5 plus minus 1 under root 25 minus 24 divided by 2. So we will see that here you can see there is a value will come 5 plus minus, and what is the value of this? This value will become a final value will come 1, and here is minus also. So write down divided by 2. Now okay, now we will write down this in this way. Okay, here you can see that first minus 1 minus 5 minus 1 divided by 2, and the second value will be minus 5 plus 1 divided by 2. So as you can see, this will be equals to, because there will be two values of x. In one we will find one value by putting minus here, and another we will take another sign, that is plus. So it will be minus 6 by 2 and this is minus 3. And in this case minus 5 and plus 1, we will get minus 4. We will get minus 4. So minus 4 divided by 2, we will get minus 2. So the roots of this equation are x equals to minus 3 and minus 2. So in this way we will find out the roots. First we find out the nature of the roots, and then as you can see here we find that the roots will be a real number, and as you can see the values of x is minus 3 and minus 2. So in this way we can find out the values. And there is another equation. If I take equation, for example, there is another equation, that is x square plus 2x plus 1. When you will solve, then you will find that b square minus 4ac will be 0. And when you solve this equation, you will find that the roots will be we will find out by putting in this formula minus b plus minus under root b square minus 4ac divided by 2a. So you can see the value of v is 2 plus minus under root here will be 4 because square of 2 minus 4 into 1 into 1 and divided by 2 into 1. So this will become 0, and you will see here is minus 1. So you will see that the value is minus 1. You will find the value that will come minus 1. So the roots will be minus and minus 1. Okay, so let's come to the next example, and that is x square plus x plus 1 equals to 0. Here we will find out the nature of roots b square minus 4ac, and here as you can see a is 1 and v is also 1 and c is also 1. So we will find out the value of b square minus 4ac, 1 square minus 4 into 1 and 1. So the value comes 1 minus 4, that is minus 3. So as you can see, we find the value of b square minus 4 AC, and this value is negative. That is why roots will be imaginary. Okay, roots will be imaginary. Now we will find the roots, and the formula of finding the roots is minus b plus minus under root b square minus 4ac divided by 2a. Now we will put the values minus 1 plus minus under root 1 square minus 4 into 1 and 1 and divided by 2 into 1. Okay, now you will see minus 1 plus minus, and here you will see 1 square is 1 and minus 4 here will be the minus 3. Yes, and this is 2. Now I can write down this minus 1 plus minus. I can write down this minus under root 3 in the form of minus 1 and under root 3. Okay. Here you can see the under root. When I comes in under root, so you will see that this is a imaginary number. This is a imaginary number, and this is denoted by iota. Iota, that is I. So this is our imaginary number, this is not a real number. So we will write the value of x minus 1 plus minus I under root 3 divided by 2. Now we will write the two values of x. One is minus 1 divided by 2 plus I under root 3 divided by 2, and the second term is, second root is minus 1 by 2. Here I took plus, so I will take in next value minus, and this is root 3 by 2. So as you can see, these are not real, this is not a real solution, this is, there is a imaginary solution, imaginary value, and I can write down this is as it is a plus IB form. Okay, this is a plus IB form, this also and this also. So these kind of values are called complex number, and complex number are denoted by Z. Keep in mind, complex number is always denoted by Z, and they will be in the form of A plus IB. So my dear students, this is our complex number. Yes. So you can see that we started from here. We started from a function. And what is function? Then from function there is a this was a polynomial function. And then we find out the quadratic equation from this polynomial function, and now we solve the this was our quadratic equation. First we solve our quadratic equation, and then we find out the different kind of solution. There was a real values, real solutions, and now we find out that there was a solution. Those are not real number, those are imaginary number, and this is called as complex number. So my dear, understand this, that if minus 1 comes under root, then it is called as iota. Okay, keep in mind this is iota. Okay, so as you can see here, this is also a quadratic equation, and we find the solution of x square minus 4, and as you can see, this is the solution of this equation, and we find the solution of this quadratic equation. Here you can see v is 0, in this case b is 0, here also v is 0. Here you can see and now this is the we represent our quadratic equation in this format. This is our quadratic equation, and this formula is used. Keep in mind the solution, if this comes, if v square minus 4ac comes less than 0, then solution will be a complex number. So keep in mind, and I have already proved that by showing you, by solving this equation, that this is true. Okay, now here you can see this is a formula for finding the value of x, roots of a. Okay, now this is a complex number. This is how we represent complex number. We represented a plus IB form, and it is denoted by Z. So I denoted complex number by Z. These are some examples of our complex number: 2 plus I, 3 plus 2I. Basically this is a you can see a to 0 plus IB form है. Here this terms become 0 there because multiplication is 0, so that's why we find I. Okay, now yes, here a term comes conjugate. Yes, here you can see there is a term comes, and what is that? That is conjugate. So we will see that what is this and what is conjugate. Now we will study about what is conjugate. Okay, we will see what is conjugate. As you can see, if there is a complex number, that is z equals to a plus ib, and now we have to find the conjugate of this complex number. So if I write down this a minus ib, I just change the sign before I. Here was plus and I put in the place of plus I put minus. So this will be the conjugate. So this is the conjugate and it is represented by a z bar. So this is the conjugate. Okay, we will use conjugate. Now there will be question in your mind, then why we find the conjugate. It will help us in upcoming concept, you will see. Okay, so as you can see, this was the conjugate. So this was the our complex number, so the conjugate will be this. This is our, and it is represented by z bar. So you can see here, you can see some examples of conjugate. As yes, this is a complex number and this conjugate of this complex number will be this, and conjugate of this complex number will be this, and for this complex number the conjugate will be this. Now the another things come, the modulus. What is modulus? Yes, first you will you have to understand that what are these terms, and the use of these terms I will tell you later. First you should understand what is modulus. So if there is a modulus, if there is a complex number that is z plus iv, and you have to find the modulus of this complex number, then you will find in this way. Yes, you will find modulus by using this formula. Okay, and you can see it will comes always it will be a positive real number. Yes, now come to this. There is a z inverse and it is equals to this. My dear friend, if there is a complex number that is z, so there will be a multiplicative inverse. What? Listen carefully. Multiplicative inverse. And what is a multiplicative inverse? If I that complex number, if I multiply that complex number with this, then I will find 1. So this is our multiplicative inverse. Z inverse is what? As you can see, multiplicative inverse. And how you will find the multiplicative inverse of a given complex number? You will find, first you have to find conjugate. Okay, then you will find modulus. Yes, that's why I taught you first conjugate, how to find conjugate. As you can see, I told you that how to find the conjugate. Now we learn how to find the modulus, and now we use both terms, modulus and our conjugate. So we find modulus and conjugate and modulus to find the this multiplicative inverse. Multiplicative inverse. So this was the use. Okay. Yes, you can expect a question from here. This is a very simple concept. As you can see, this is nothing. As you can see, we represent, this is a type of representation of our complex number. As you can see, this is a real term, this is a real, and this is imaginary. So we can write down our complex number in another form, and that is called complex. That is called polar representation. That is polar representation. I can represent any complex number in this format. In this format. Okay, look at here. Okay, look at here. So as what we have to find? We have to find the, okay, watch carefully. Yes, this is a complex number and we have to find this. First we will start from end and we have to find this will be our answer. And answer of what question I will tell you later. First look at this. We will find cos theta plus I sin theta. Now you will see how to find r. We will find r equals to under root a square plus b square. Here we will find r, and you will ask, sir, how to find theta? Theta, how to find theta? Theta will find theta equal to tan inverse b upon a. So this is how we will find theta. Okay, we find r, we find theta, but a, what are a and b? Okay, z equals to a plus ib. So from here we find a and b, and then now I will write down in downward direction. Yes, so we have to move in this direction. Yes, in this direction we will move, and we will find out the, this is the polar form, polar representation. This is a polar representation. Okay, so you have to do this by following this pattern method. Okay, now yes, okay, come to the last. As you can see, the expected question, how the question will come. As you can see, question will come, he will ask you, first he will ask you find multiplicative inverse, that is z inverse. Next there will be simple calculations, such that he will say to you 1 plus I multiply this by 2 minus 3i. So this kind of question he can ask you, simple multiplication. Or he can ask you convert into a plus ib form. Yes, there will, this is also a calculation. Suppose there is 1 plus I, 2 plus I. So what you will do, you will multiply this, multiply with the conjugate of denominator, that is 2 minus I and 2 minus I, and you will solve this, and you will convert it into a plus ib form. And the last is, he can ask you to convert this into polar representation or polar form. So you can convert it into a polar form. Okay, suppose as earlier I solved a question, and that was yes, as you can see, there was equation, and the equation was this x square plus x plus 1. We solved this quadratic equation, and we find the roots, and roots were, one root was this and second was this. So I took this root. Okay, here I will take one of this root. I can take this root or this root. Both are complex number. So here we take this, or we can take this, anyone we can take. So yes, you can see here, we take a complex number, and that is minus 1 by 2 and minus iota root 3 by 2. So this is a plus iv form. This is in a plus iv form. Okay, now we have to convert it into polar form. We have to convert it into a polar form. So first we will write what is a. A is minus 1 by 2, and what is v? V is minus root 3 by 2. So can I find r? Yes, I can find r, and that is r a square plus b square. Okay, under root minus 1 by 2 square and plus minus under root 3 by 2 square. Now we will solve it, and you will see this will come 1 by 4, and this will come 3 by 4. So value will be 1. So the value of r is 1. Now we will find the theta. And what is theta? Theta equals to tan inverse b upon a. Here also we will put the value of v and a. As you can see, theta equals to tan inverse. And what is the value of b? minus root 3 by 2 divided by what is the value of a, that is minus 1 by 2. Okay, so as you can see, this will cancel out by this and this by this, so theta will come theta will come tan inverse root 3, and this is the value of 60 degree, or I can write down in radian pi by 3. So what will be the polar form? Yes, so the polar form will be z equals to r, and what is the value of r? That is 1, and cos theta, and what is the value of theta? Pi by 3, plus I sin pi by 3, or I can write down z equals to cos pi by 3 plus I sin pi by 3. So yes, so this was how we change our a plus iv form into a polar form. So here you can see that is how we change the form of our complex number. Yes, so this kind of question you can expect, and the tougher question, one level more question we will discuss, and don't worry about the problems. First you have to understand the basics. If you understand the basic, then we will practice our questions. So you have to practice, and they are these kind of questions you can expect. Multiplicative inverse, simple calculation, that is multiplication, divide, or convert it into a polar form. So this was our topic, complex number and quadratic equation. Next topic we will discuss inequalities. Inequalities, very small topic. I will try to upload that lecture as soon as possible. So keep your study up, and yes, so let's meet in the next class. Till then, bye bye.